Thanks for joining me. In this video, we will be just doing a quick introduction of logarithmic and exponential functions, how they kind of relate to each other, and how you can rewrite one in the form of the other. So first, the important thing to realize is that a logarithm is just the inverse of an exponential. So it's kind of one and the same. You can write it from one form to the other using the property given here. Log base b of x, so this is red, log base b of x is y, so log base b of x equals y, and that's the same as b to the power of y is equal to x. Notice that I said log base b. So the b here is the base. If you recall, when you're dealing with exponents, you had a base and a power, or a base and an exponent. The base is what's raised to the power. Notice in both cases, the base is b. So in either scenario, you have a logarithmic equation or you have an exponential equation. In either case, you have a base, and you can identify it. That's where you want to start when you're going to write an equation in a different form. So if you're starting with the logarithmic form and you want to change to exponential, you would start by identifying the base, and then you would go across the equal sign. So you would say b raised to the y is equal to x, and that's exactly what we have on the right. If you want to start in exponential form and rewrite it in log form, you would start by identifying the base and writing log. So log base b, you go across the equal sign of x is equal to, go back across the equal sign, y. Let's look at some examples, and I think that will help you see how to do this. So in number 1, we have 3 squared equals 9. That's in that's in exponential form. The directions say rewrite in log form. It's pretty easy to tell if it's in logarithmic form because it says log, or ln, which is natural log. If it doesn't have that, then it's in exponential form. So number 1, we're going to identify the base. So the base is 3. So I'm going to start by writing log base 3, so the 3 gets written as a little number, a subscript, of, go across the equal sign, 9 is equal to, go back across the equal sign, 2. So to write it in logarithmic form, you start with a base, log base 3 of 9 equals 2. And that's it. Number 2, we're going to do the same thing. Identify the base. The base is what's raised to the power, so the base is 4. So we'll start by writing log base 4 of b is equal to a. And that's now written in log form. All right, number 3. We want to write in log form, so we can start by writing log and identifying the base. Notice that this time the part with the exponent is on the right, so the base is m. So it doesn't have to be the left-hand side where you start. Wherever the side is with the exponent, that's where you're going to start. So log base m, go across the equal sign, of 8 is equal to, go back across the equal sign, negative 9. And that's it. Number 4. We didn't talk about an understood base, and so this is a good time to do it. If you have a logarithm, log is called the common logarithm. So the common log, its understood base is 10. So if there is no base written, it's understood to be a 10. There is another logarithm, and it's called the natural logarithm, or the natural log. and it is ln. So ln. Its understood base is e. So e is a number like pi. Since it is an irrational number, we use the letter e to represent that specific number. And so the base for natural log is understood to be e. So when you see an exponential equation like a number 5 that has the e, generally you use the natural log instead of the common log because the base will be the e. So that being said, let's look at number 4. So number 4, I'm going to identify the base. It's 10. So I'm going to write log base 10. Now since the 10 is understood to be there, I do not have to write the base 10. So log base 10 of 1 over 100 is equal to -2. So again, that 10 is still down here, still a subscript of 10, but it's understood to be 10. That's just the generic base. So if it's a 10, you don't have to write it. Okay, the last exponential that we're going to rewrite in logarithmic form is number 5. It's e to the power of 3 is equal to x. So first you identify the base. The base this time is e. So that indicates that you should use the natural log. So the natural log base e, since the base of a natural log is understood to be e, you don't have to write the e, of x is equal to 3. And that would be it. In the next few examples, we're going to go the other way. So now they're giving us the logarithmic equation, and they want us to write it in exponential form. The process, thankfully, is exactly the same. So what we're going to do is first identify the base. So the base is the subscript, the small number, right after the log. So base 5. So we're going to start by writing 5, and that's a normal size number. And that's going to be raised, go across the equal sign, to the third power, is equal to 125. And so the 125, that's what I'm taking the log of. That's called the argument. So it's the base 5 raised to the third power is set equal to the argument, set equal to 125. And that's it. Number 7, we have a logarithmic equation. We want to rewrite it in exponential form. So we start by identifying the base. So 3 raised to the 5th power is equal to x. And that's it. Number 8, identify the base. So the base is 4. So 4 raised to the power y is equal to 16. Number 9, identify the base. Notice that there is not a base here. So we need to know that the understood base, which would be right here, is 10. So that's going to be the base that we write for our exponential equation. So 10 raised to the -5th power is equal to m. And notice that every time I identify the base, I'm then going back and forth across the equal sign to finish writing my equation. All right, number 10, a couple of things different here. So first, it's a ln, a natural log, instead of a common log. And second, notice that the log is on the right-hand side. For some reason, it kind of throws me off when it's on the other side, but that's okay. First, identify the base. So the base is always with the log. So since it's a natural log, that means the base is understood to be an e. So it's going to be e, go across the equal sign, raised to the y, is equal to 3.